Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss all about integrated circuits. Let's begin. Before starting into integrated circuits, let's discuss about electronic components. In electronics, we deal with various kinds of electronic components like resistor, capacitor, diode, transistor, SCR, we say it as silicon control rectifier, vacuum tubes, inductors, etc. So, on the basis of their mode of operations, we classify the electronic components into three categories as active components, passive components and discrete components. So, what is active components? The electronic components which can be used to introduce a gain into a circuit are known as active components. When these electronic components are within that of circuit, it helps a gain into that of particular circuit. They require external source of energy to perform their intended functions, and they have the ability to modify the input and output power. Means the output power may be greater than that of input power. The examples of active components as transistor, triode valve, tunnel diode, etc. are the example of active components. Next, passive components, the electronic components which cannot be used to introduce a gain into a circuit are known as passive components. Active components provides the gain into the circuit, but passive components cannot use to introduce gain into a circuit. They do not possess internal energy source, but in active components it has both external as well as internal active energy source. In such components, the output power cannot be greater than input power, but in active we say the output power may be greater than that of input power. In case of passive electronic component, that typically absorb energy without creating any action gain. There will be no such action, but that electronic components will absorb some kind of energy. Some examples of passive components as capacitor, resistor, inductor, LDR, the full form of LDR as light dependent resistor. Light dependent resistor, or we call it as photoresistor. These electronic components are some example of passive components. Next, discrete components. Discrete components basically we define as an elementary electronic device that constructed as a single unit. Discrete, the name indicates it is distinct one, means that electronic device constructed individually. So, we prefer examples as we say electronic elements like resistor, capacitor, diode, tunnel diode, transistor, SCR, which is known as silicon controlled resistor, vacuum tube, LDR, that is the light dependent transistor or light dependent resistor or photoresistor, and inductor, etc. are separately manufactured. These are separately manufactured physical entities and joined each other by wires. And these particular electronic components are mounted distinctly. They are also mounted distinctly, or we can say individually. These elements are known as discrete components. These elements are known as discrete components. Okay. As these elements are manufactured individually and they are mounted distinctly inside that of circuit, so these elements are considered as discrete components. In this way, the electronic components are classified as active components and passive components on the basis of their mode of operations, and discrete components on the basis of its manufacturing way. Next, integrated circuits, or we call it as ICs. Integrated circuits. In the present world, we can't be imagined without computer and cellular phones. While dealing with these essential gadgets, we all come across a word, that is microprocessor. Always we say microprocessor in computer or Android phones. The microprocessor is a complicated circuit that processes all information in the computer, also in case of cellular phones. It keeps track of what keys are pressed. Accordingly, it remembers if mouse has been moved. Therefore, the complicated circuit is a compact semiconductor chip in which thousands of tiny circuit components, thousands of small, which can be said as tiny circuit components such as diode, transistor, resistor, capacitors, etc. are developed in the same crystal. These components are manufactured from that of same kind of crystal, and it is known as the integrated circuit. In shortly we say it as IC. There are so many advantages as well as disadvantages, or we can say it as the drawbacks of integrated circuits. We discuss the advantages of integrated circuit as it is extremely small in size. It is very small due to the fabrication in a single chip. That is why the ICs are extremely small in size. There are least number of connections. Therefore, it promises high reliability and low power consumption. Miniaturization results in low weight and easy portability. Miniaturization means it is very small in size. In small in size, there are a lot number of electronic components. Therefore, due to the small in size, it has low weight and easy to portable. It is capable of performing under extreme hot environmental condition and low cost of its production. For the production of ICs, there will be less amount of fees required. Use of ICs makes the circuit layout simple for electronic equipments. When we rearrange the electronic equipments for using ICs, it is very easy, or we can say it is very simple for electronic equipments. Lightweight, due to its small size, it has low weight and easy to portable. So, that feature, lightweight feature, promises wide application in aircrafts as well as spacecrafts. Any kind of electronic instrument has advantages as well as disadvantages, or we can say drawbacks. The integrated circuits or ICs also have some drawbacks. ICs are not repairable, means if a IC is damaged, then it cannot be replaced. A new IC is introduced. Performance of PNP transistor in case of ICs is not of to satisfaction. Power dissipation capacity of IC is very small. It produces noise during the operation in some cases. Its components such as resistors and capacitors are voltage dependent. The two components of IC, that is resistor and capacitor, that depend upon voltage. It is too delicate to withstand under high rough handling. Due to its delication, we can't roughly handle that integrated circuits. These are some advantages as well as drawbacks or disadvantages of ICs. Next, the classification of ICs. On the basis of mode of operation, we classify the ICs into two categories. One is linear IC, another one is digital IC. let me discuss one by one. Linear IC. The integrated circuits are said to be linear, as the name indicates linear, in which the operation is such that their input output relations remain linear. If we provide some kind of voltage, then output we achieve some current. So, if we plot a graph between input and output, so the graph show a linear in shape. A linear integrated circuit is an analog device. That linear integrated circuit is an analog device, means that operates over a continuous range of input levels. In fact, it is characterized by a theoretically infinite number of possible operating states, various kinds of possible states we show for its function. The output changes continuously along with the change at input end. If we change in input section, ultimately the output sections accordingly changed. When a certain input range, the amplification curve of a linear IC is straight line, in which the output and input voltage are directly proportional. As we say, the graph we achieve, that is linear. So, if we consider the amplification curve for that of linear IC, that gives a straight line, Basically, that straight line indicates the output voltage and input voltage both are directly proportional. If two quantities are directly proportional with each other and we plot a graph, that graph is linear in shape. Next, digital ICs. The ICs are said to be digital. Here the ICs are said to be linear. Why? The input and output relations remain linear. In that particular case, it is said to be digital when their operation involves two steps only, and in case of switches, we see the switches as it is capable of processing either on or off states, 1 or 0 states, but do not operate in between these two. Thus, a digital IC has a finite number of discrete input, but in case of linear ICs, there are infinite number of possible operating states, but in case of digital ICs, since it is act on and off, there will be no such intermediate state. Therefore, it has a finite number of discrete input and output states like an analog IC. Digital ICs work obeying Boolean algebra to process high and low signals. High signal treated as 1 and low signal treated as 0 in case of Boolean algebra. By using the Boolean algebra concept, we can easily define or the characteristic property of digital ICs are categorized. With the classification of ICs under the mode of operation, we classify linear IC and digital IC. These are some basic features of linear IC and these are some basic features of digital ICs. Next, scales of integration in ICs. In integrated circuit, we know there are millions and billions of transistors are used. With the progress of technology, millions and billions, millions, that is 10 to the power 6, billions 10 to the power 12. there are millions and billions of transistors could be placed on one chip. The scale of integration in that of integrated circuit refers to the number of components developed on a standard IC. In other words, we can say it is the density of components within a chip, what the number of transistors or logic gates are within that of chip. Based upon the number of transistor and gates grown in a chip, we classify the scales of integration as follows. As we say, that is group scale of integration, number of transistors, in which year the technology developed, number of gates, number of gates. First, SSI, named as small scale integration, small scale integration. Here the number of transistor from 1 to 10. The technology developed in the year 1964. Number of logic gates from 1 to 12. MSI, that is medium scale integration, medium scale integration. Number of transistors from 10 to 500. In the year of 1968, number of gates 13 to 99. Next, LSI, that for large scale integration, large scale integration. Number of transistors from 500 to 20,000. In the year of 1971, number of gates 100 to 9,999. Next, VLSI, very large scale integration, very large scale integration. That is from 20,000 to 10 lakh. In 1980, that from 10,000 up to 99,999. Next, ULSI, that is ultra large scale integration, ultra large scale integration. The number of transistors greater than 10 lakh. Year 1984. The number of gates here 10,000 to more. In this way, we classify the scale of integration as follows. the scale of integrations as SSI small scale integration, MSI medium scale integration, LSI large scale integration, VLSI very large scale integration, ULSI ultra large scale integration. So, VLSI, that is very large scale integration, that period started in 1980 and is continuing through up to present era. The development started with hundreds of thousands of transistors in that of early 1980 and it continues beyond 10 billion transistors as of today's 2022. In this way, the scales of integration in ICs are classified. Next, the idea of wafer and chip. What is wafer? Basically, wafer is a circular, extremely flat, highly doped silicon slice on which IC is produced. In that of wafer, one side of the wafer is smoothed by polishing. After polishing, it is thoroughly cleaned and dried. It is cleaned by using purity low particle chemicals. How wafer is produced? We say a base or substratum is necessary to grow that kind of components. So, a silicon base is prepared first. First we prepare a silicon base, and silicon is the best suited to integrated circuit fabrication. A cylindrical p-type silicon, we consider a cylindrical p-type silicon crystal that is grown from sand, and the length of that of silicon is about, that length is about 25 centimeter, that is the length. And its diameter about 2.5 cm. And the silicon and that of cylinder, that is a p type silicon cylinder. That cylinder is then cut carefully by a diamond. That silicon we cut by using a diamond carefully, and we saw that cylinder is cutted into thin slices, that is cutted thin size slices like this. These are the slices. And the slices having the thickness of the slices, the thickness is 200 micrometer. One side of each slice is finely polished. Here the diameter D is equal to 2.5 cm and each slice is called a wafer. Each slice is called a wafer. Next, chips. First we say that wafer is divided into hundreds of tiny areas. An IC, which is said as the integrated circuit for a particular electronic function, is formed each tiny area. That particular tiny area is responsible for a particular electronic functions. That is why each tiny area is known as a chip. So, with the help of this video lecture, we understand electronic components, active components, passive components, discrete components, integrated circuits, advantages of integrated circuits, drawbacks of integrated circuits, classification of ICs on the basis of mode of their operation as linear IC, digital ICs, scale of integration in ICs as SSI, MSI, LSI, VLSI and ULSI, the idea of wafer and chips. So, with this useful and informative notes, let me wind up this session. Thank you.